Okay, what I think is happening on this graph is here we have time increasing, and here we have displacement increasing. So from here to here, we're getting further away from our start point. So if you label this as just 1, 2, 3, 4, etc., 1, 2, if this is our displacement, which we often call S in meters, if it says our time, T, in seconds, all right, then in 3 seconds, we've gone 2 meters, okay? Notice this is a straight line. This straight line means that we're going from A to B, from 0 to 2 meters in 3 seconds at a constant speed, or a constant velocity, because that speed has a direction, okay? So it's a constant velocity, so the straight line means that we have a constant velocity. So that constant velocity then, what is it? Well, we've gone 2 meters in 3 seconds. So it's 2 meters in 3 seconds. So we've gone 2/3 of a meter in 1 second. Or in other words, 2/3 meters per second. Notice that 2/3 is actually the same as the gradient. So our gradient gives us our velocity. So the gradient of our line gives us our velocity. With that in mind, the second part of the graph, we are traveling 3 meters in 3 seconds. So our gradient in this case, or the second part of our graph, for every 3 to the right, we're going 3 down. So our change in y is -3, and our change in x is 3. So our velocity then is going to be -1 meters per second, which makes a lot of sense because we're coming back towards where we started at 1 meter per second. So it's 1 meter per second in the direction of backwards, back towards where we started. Then we have an interesting part of the graph here, where we are horizontal for a moment. Notice that means our displacement doesn't change. We are staying the same distance or the same displacement away from where we started, which means that our velocity is 0. We're not traveling anywhere, and that makes sense because our gradient is also 0. So our velocity is also 0 meters per second. And then for the final part of the graph, you can see that we're going up here, we're going and we're going back to where we started, but in 1 second we've travelled 1 meter. So our change in y is 1, our change in x is 1, our gradient is 1, so our velocity is 1 meter per second in the positive direction. Now all of this is considering the fact that this is a positive direction. And our displacement here is one-dimensional. It's either forwards or backwards. There's not 2 dimensions to our motion. It's just a one-dimensional motion, either going towards an endpoint or going away from our home position or back to our home position. All right. So whenever we talk about things in mechanics and motion, we're talking at this stage we're talking about motion in one dimension, forwards or backwards, and displacement is distance travelled away from or towards a particular given point.